region maximizes the objective function. So we are find out what point in this region maximizes our objective function. So x is greater than 0. We know x equals 0 is the y-axis. So we have that, and we know x is greater than 0 is going to be on the right side of this. So I'm just going to shade very lightly. We're dealing with the right side here. And then y equals 0, that is the x-axis. And we're dealing with above that I'm dealing with this region because that's where those two overlap. Okay, next let's do, this one's kind of turned around a little bit. So we might want to think of this as y is less than negative x plus 4. So we'll graph y equals negative x plus 4. So we'll go up to 4. And then we want to get our slope. And then I'm going to use a straight edge. To get that. And this is less than. So now we're zeroing in on the region here. Let me grab another color to be more clear. We're looking at this triangle right now. Every graph that we add zeroes in our region. And our last piece is y is less than or equal to 1/3 x plus 2. So plus 2 up 1 over 3. So we're looking at this region down here. And we are less than. So you can see we have this polygon. Four sides, and I'm going to darken in that region. So what we're looking for is we need to point this region. 1, 2, 3. Okay, let's label them. Some of them are pretty easy to see. This one is 0, 0. This one is 4, 0. This one is 0, 4. And this guy did not land on an exact point. Close. It looks like I'm about 1.5 and 2.5. Now to find, and I did that roughly, okay, but to find that exact point, I would set this line, negative x plus 4, equal to this line, 1/3 x plus 2. Let's do that. Negative x plus 4 equals 1/3 x plus 2, and I would solve. Okay, let's multiply everything by 3. So that gives me negative 3x plus 12 equals x plus 6. So we'll move our x over by subtracting. Negative 4x plus 12 equals 6. Move our 12 over by subtracting. And we get x equals 3/2. That was pretty close, huh? And then we can substitute in halves in for x here to get the y value being 2.5. Okay, so now what do we do with those? Now that we know these, and you know what? I chose the wrong one here. We need this guy, which is 0, 2. Thank you for catching that. All right, now what do we do with these 4 points now? Well, we have to see which one's going to make this objective function the biggest, because remember, we're looking for the maximum. So I'm going to make myself a little chart over here, and I'll have my chart, y in my chart, and then c. And remember, x and y are coming from my vertices. So I'll do the first one, 0, 0. Then we plug in 0 for x, 0 for y, and I get 0. Let's do 4, 0. And x, 0 for y, and I get 16. put in 3/2 for x and 5/2 for y. Use your calculator if you need to. That gives me 6 minus, and then last put in 0, 2. So you get 4, 0 for x, and 2 for y, you get negative 10. So the point in this region that makes the objective function at a maximum, that point is 4,